Okay, so today we're going to be starting 10.5 quadrantal angles and reference angles. But first we're going to get into some bell work, remembering how to use the law of cosines and the law of sines. So our first one is we need to solve the whole triangle, meaning we're going to have to solve for the side length B, angle A, and angle C. Based off of this information, we have a side, angle, and a side, and the only law that we can use that references that is the law of cosine. So that allows us to solve for B. So we're going to do our B squared, because that is our reference angle it relates to, equal to 15 squared plus 20 squared minus 2 times 15 times 20 cosine of 124. Throwing that into your calculator and then taking the square root, you're going to see that B equals approximately 30.99 or 31. We're going to go with 31 for this one. Is that okay? It's really close. So we now have B to be 31. Since we have B to be 31, we have three sides. So we can continue with the law of cosine to solve another angle, or we can use law of sines. I prefer law of sines. So I'm going to look for angle A. So angle A is correlated to 15, and we now know 31 and 124 are correlated. So we're going to do sine of 124 over 31 has to equal sine of our unknown A over 15. Cross multiplying, we're going to get 31 sine of A equal to 15 sine of 124. Divide by 31, and since we are looking for an angle, it means we're going to be doing sine inverse of 15 sine of 124 divided by 31. When you plug that into your calculator, make sure that your numerator is in double parentheses, because if not, it does some funky things. So A is going to equal 23.6 degrees. And our last step is we need to solve for C. Solving for C, well, we have two lovely angles, and now we just need a third. So we're going to take 180 minus 124 minus 23.6, which is going to mean that C equals 32.4 degrees. Remembering how to solve for a triangle, it's really important we get that stuff down. On bell work of number 2, we are going to tell all of the possible measures for angle R. So that right there should indicate, oh yeah, we're going back into sine, making sure we understand everything, and that there are two options for R. So we are looking at R that correlates with 41, and we were also given 39 that correlates with 28. So we can set up our problem of sine 39 over 28 equal to sine of R, our unknown, which correlates with 41. We cross multiply to see that 28 sine of R equals 41 sine of 39. Divide by 28, and since we're looking for an angle, it means we are doing the sine inverse of 41 sine of 39 divided by 28. We're going to see that R equals, when you plug that into your calculator, 67.1 degrees. But we also need to check for that second possible angle. So what we do here is we take 180 minus 67.1, and we're going to get 112.9 degrees. So those are our two possibles. We know this one works, but we have to check this one. So we take this and we add our known angle of 39 to see that this is going to be 151.9, which is less than 180. So therefore, both of these angles are R. Okay? So we now know that there are two possible angles for R. These are great reviews of the law of cosine, law of sine, and the law of sine looking for two possible angles. So getting into the lesson for today, our essential question is how are sine, cosine, and tangent defined for angles of 90 degrees or more? So we're looking at a circle now, and we're looking for when the angles are 90 or more, as in the actual points of them. and we're looking for what those mean. So our first thing is to remember what sine, cosine, and tangent means. It means so, ka, and toa. And we're going to learn another thing here, okay? So our first understanding is this is a unit circle. A unit circle is a circle based at the origin, so I will remember that, origin, where from our origin to the circle is our radius r, that when we're connecting to it, to find out things, it can create a right triangle, which is really important in how things are going to be working here. And this is our x value, and this would be our y value, with our angle always being the angle that is closest to the origin. The angle is never up here, it is always in this area, okay? So, remembering sine, cosine, and tangent, we know sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. For when we use the unit circle, though, there are other meanings. In this unit circle, we don't have opposite, hypotenuse, and adjacent right away because we've labeled them differently. We have radius, y, and x. This works the same way. Once we know this angle, opposite is y, and our hypotenuse is r. So sine is the same thing as y over r. Using that same area, cosine, adjacent over hypotenuse, so it's the same thing as saying x over r, and our tangent, which is the same thing as saying opposite over adjacent or y over x. So you do need to start understanding these guys because this is how you're going to start to get answers based off of the reference angle, which we'll talk more about, and it allows you to see how we solve a unit circle. These are important. And what we first need to talk about are the quadrantal angles. Quadrantal angles are angles that terminate on the axis. And in retrospect, or English, it really just means the multiples of 90 degrees, or pi over 2. Okay, so multiples of 90 or pi over 2. And that's just meaning the points where our axes are actually touching. We'll talk more about that in just a second. And so when we do determine trig values, which we got here, for quadrantal angles, which are multiples of 90, we are using the unit circle. We have to use the unit circle. It helps us out so much. Makes our life super easy. Okay? So, now that we have established our ratios, we're going to now look at a full unit circle and what that represents. So a unit circle, again, as a reference, is centered at the origin of 0, 0. And we know that our radius r, so this is for everything, our radius is going to equal 1. It is always 1. So it's for whatever r from the origin to touching the unit circle is our radius of 1. Okay? Our quadrantal angles specifically happen at these points. So when this is at our pi, our 2 pi, or our 0, or our 360, it is at point 1, 0. Because remember, r is only 1, so from here to here is an x of 1, and our y is still at 0. Another point that is a quadrantal is 1 up, so that means we are at 0, 1 as another quadrantal point. And our last two correlate with where we are touching the unit circle on our axes. So if this is 1 going this way in the x value is -1, 0, and going down is 0, -1. These are really helpful and the beginning of understanding a full unit circle. If you're going on to trigonometry, you're going to have to remember a lot of stuff. So if you can remember these 4 points, that does help you come faster. Okay. So now we're going to get into what we mean by solving, specifically quadrantal ones. Okay, on the unit circle. So our first example is cosine pi over 2. So if you remember from last lesson, we were trying to remember, all right, well, where is it in this quadrant? Where is our angles? Where is it at? From there. Please do not, in this case, convert. Do not convert to degrees. You're gonna have to know your radians. So here, pi over 2. Pi over 2 is the same thing as 90 degrees. So this angle is just pointing straight up. And because we know that angle is pointing straight up, we are at this point on our unit circle, this invisible unit circle, we are at 0, 1. But we need to solve. And this says cosine. Well, solving cosine, remember, we said is adjacent over hypotenuse. But remember, adjacent over hypotenuse, back from what we just stated, is our x over our r. Okay? So we have x over r. Well, we have an x and a y value. And what did we say r is always? R is always 1. So we have an x value and an r value. So cosine pi over 2 equals x of 0 over r of 1. So cosine pi over 2 equals 0. That is your answer. Okay? This is the basics. We're going to get more into it, but we're trying to see that based off of what we've been given, we know our angle is here, therefore it is at this point 0, 1, and our radius being 1, we have enough information to solve for cosine pi over 2. We're going to do the same thing for tangent of 270. If you remember 270, it's 90, 180, 270. So our angle is currently here at 270. At the point, so we're at x is 0 and our y is -1, so this is our x and our y. Our r is always 1, but we are solving for tangent. Remembering back again, tangent is opposite over adjacent, but since we really don't know any reference points of opposite over adjacent of a straight line, we have to see and remember that it is y over x. So we take our y value of -1 and our x value of 0. We didn't have to use r. But remember, what is anything divided by 0? It is undefined. So our tangent of 270 is undefined. If you plug that into your calculator, you would have gotten an error, but please put undefined because that is how you would represent it. So our answer is undefined. If you are starting to get the hang of it, go ahead and see if you can attempt the next few examples. If not, please follow along and see if you get your answers to be correct. Okay. Our next one, sine of 3 pi over 2. Again, remembering where everything is at. A quarter or a box is 90 degrees or pi over 2. So if this is pi over 2, this is 2 pi over 2, and this is 3 pi over 2. So 3 pi over 2 says I am right here pointing down, and I am at this point 0, -1, our x and our y values. Once again, our r is 1, never changes. And we're going to look for sine. Well, sine is opposite over hypotenuse, or the same thing as saying y over r. Our y value is -1 and our r is 1. So we take -1 divided by 1, we get -1 as our answer. Starting to see how this is working. Okay, so for cosine of -pi. So remembering that -pi, we now go counterclockwise, and half of a circle is pi, so that means we are still here, and this is at point -1, 0, our x and our y value. Our r is always 1. Cosine is adjacent over hypotenuse. But since we, again, don't know adjacent or hypotenuse, we have to remember that cosine is x over r. And our x is -1, and our r is 1, so our answer is -1. Which is the same thing as sine 3 pi over 2. So when you are doing these on quadrantal angles, only on these quadrantal angles, you're going to get an answer of 0, 1, -1, or undefined. You have 4 choices. That's it. But only for quadrantals. But what happens when we start getting more into it? Into what is happening when we go past 90 degrees. For an angle greater than 90 degrees, so anything more than 90, 91 right there, we're going to use what is known as a reference angle. Reference angles are huge. Again, this is why we're talking about it now, so when you go to trig, you're like, I understand. Reference angles is a positive, remember they're always positive, acute angle between the terminal side of an angle and the most important, the x-axis. So we're determining a reference angle. So it is anything that is less than 90 degrees. It's always less than 90 degrees. And we're going to have to draw the angle, the related triangle. So we're going to look at the triangles now. So we're getting more into what's happening. And we need to tell the reference angle. Reference angles are important. You need to get it down for this one because your next lesson deals a lot with reference angles. Okay? So our first stuff at number 5 of an example is we are drawing the angle, the triangle, and we're telling the reference angle. So 210. Well, 210, we have to get to where we were drawing our angles from last time. So we know 90, 180, this is 270, so we know it's in here. So we know our 210 is in this area. Well, we need to figure out how to get our reference angle. The reference angle is between the terminal side of this angle, so this is your terminal, and the x-axis. So that means our reference angle is from the x-axis to the terminal. So this is going to be our RA. To create the triangle, you have already put the fact that this angle is together. All you have to do is connect the dots and you have created your triangle. Okay. So we saw that it was very close to 180 degrees. That is the one we are connecting to. But now we need to find that reference angle. To find your reference angle, it is the difference between your angle and what is to the x-axis. So what's 210 minus 180? Well, it's 30 degrees. So our reference angle is a positive 30 degrees. You have drawn the angle, the related triangle, and you've noticed that your reference angle is the difference between your x-axis and your angle of 30 degrees. That is number 5. You will have to do this on your homework exactly like this. You don't have to put the 180, but I do suggest putting what you were doing. So you get to this point, generally where it's at. You see you are closest to the 180 mark. You create your right triangle, and then you find the difference between the two. This is going to help you next lesson. Please get this stuff down. So I know a lot of you are probably going to be converting these from last week. Please do not do that. What you need to ask yourself is this closer to pi or 2 pi? Okay, so pi or 2 pi. I have 5 over 3. I don't even have to really look at the pi. 5 over 3. Well, to get 1, it's 3 over 3. Or to get 2 is 6 over 3. Is 5 closer to 3 or 6? It's closer to 6. So it's closer to 2 pi. See how I made that? I didn't do much math. All I had to know was that 3 over 3 is 1 and 6 over 3 is 2. Where is 5 over 3 closest to? That's how I figured this one out. So I am closer to 2 pi, meaning more than likely that is going to be where my x-axis is going. Since this is 6 pi over 3, and I do go this way, and I need to get to 5, all that says is now I'm going to be going down just a little bit more to get 5 pi over 3. Because this was 6, and I needed 5, I can create my triangle and my reference angle. See how that worked? I decided I was closer to 2 pi, so I knew I was over here. But I am less than 2 pi, so I go down from my area. Well, what's the difference between 6 pi and 5 pi? 6 pi over 3 and 5 pi over 3? A pi over 3. So our reference angle is a pi over 3. Okay? All right now we're doing is just looking for the reference angle. You are drawing your angle like you did last time. You are connecting it to the closest x-axis, and you're seeing the difference between the closest x-axis and your angle to create your reference angle. Okay. All right, let's do 4 more, and then the rest of it is up to you. Please come and see me if you're having troubles. Email, I get it. So looking at 7, we have another radian, 3 pi over 4. Ask the question, am I closer to pi or 2 pi? So I have a denominator of 4, so pi or 2 pi? Well, with the denominator of 4, that means 4 pi over 4 or 8 pi over 4. I am closer, since that's a 3, to 4 pi over 4. So that means I'm going to be at the pi of 4 pi over 4. So I'm definitely going to have my x-axis being there. Well, now we're looking at 3 pi over 4. And since when we start over here and go this way, I need to go back a little bit to see that this has to be 3 pi over 4, because it can't go backwards. So all I have to do now is connect my 2 axis angles and my angle to create a triangle, and now I need to find my RA reference angle. Well, what is the difference between 4 pi and 3 pi over 4? 4 pi over 4 and 3 pi over 4? Well, they are 1 pi over 4 away. So your reference angle is pi over 4. Okay? Are we starting to see things? Please let me know. 8. Once again, we are in radians, so we need to consider, are we closer, since this is negative, are we closer to negative pi or negative 2 pi? Since this has a denominator of 6, it's the same thing as saying, is it negative 6 pi over 6 or negative 12 pi over 6? Well, looking at this, I'm at a 5, so I am closest to negative pi, so that is here. So we have negative 6 pi over 6. We are closer to that because of the 5. Since it's negative, remember we do go the counterclockwise way, so we're going this way. And since 5 is before 6, we are coming backwards to see that this has to be where negative 5 pi over 6 resides. We're going to connect our 2 together to create a lovely triangle. And now we need to find our reference angle. Our reference angle is, again, the difference between the two, so how far away are they? But remember, reference angle is always positive. So even though these are both negative, we need the positive. Well, we're only 1 pi over 6 away, so therefore our reference angle is pi over 6. You have just done this. Keep doing great. I promise you're doing great. Is this okay? Doing great? Doing awesome. 2 more to go. We're almost done. So number 9, we are once again in degrees, but this time it is negative, so negative 495. Well, first things first, this is definitely larger than 1 full circle, so I'm going to add 360. When I add 360, I'm going to see that it is negative 135 degrees. So you can choose to look at 135 degrees, or if you want the positive, you will add, or you will add another 360 degrees, since you're going a full other circle, and you're going to see it is 225 degrees. So we have 2 angles, but at the same spot that we're looking at. So negative 135 is definitely less, so if I start over here and I go this way, it's definitely less than 180, but it is nowhere near 0 or 360. So I know we're going to be looking at 180. The negative of it for 135, and since we're going this way, it has to be over here. Okay. That was just for the negative 135. For 225, it works the exact same way. So as we go around the circle, okay, counterclockwise, clockwise, said the wrong thing, we can notice that this is also still a positive 180. And since 180 is less than 225, guess where 225 is? The exact same place as our negative 135. So we have made our x-axis known and our reference angle, well, our angle to where we're going. So we connect them to create our triangle. And we're looking now for our reference angle that is between the x-axis and our terminal, okay? So what we need to do is now find the difference between one of 2 things, depending if you did negative or positive, negative 180 and negative 135, or positive 180 and 225. They are the exact same answer, but remember it is positive. So either way, you're going to see that our reference angle is 45 degrees, and that is what is right here. Our last one, another radian, is remembering, are we closer to pi or 2 pi? Since our denominator is 3, it's the same thing as asking 3 pi over 3 or 6 pi over 3. Which one are we closer to? 4 is definitely closer to 3 pi over 3, so that's in our pi area. So we know that we are going to be using this x-axis of 3 pi over 3. We are positive, so that means since we are 3 pi over 3, we continue down until we make a terminal angle for 4 pi over 3. We connect our 2 lines to create a right triangle. And for our reference angle, the difference between 3 pi over 3 and 4 pi over 3 is a pi over 3. Okay. All right, well, please let me know if you need anything else. 10.6 is coming right after this one. You have to get the reference angles down. You will need them for 10.6. So, any questions? Make sure you get this going.